Assalamu alaikum wa rahmatullahi wa barakatuh. This is the first video of part 1 of chapter 8, Alternating Sinusoidal Current. At the end of this chapter, you should be able to explain the phenomena of charging and discharging of a capacitor under constant voltage and under square voltage. 2. Determine the differential equations that govern the variation of charge, voltage, and current in the RC series circuit. 3. Determine the time constant of an RC series circuit. 4. Determine the expression of the energy stored in the capacitor in the RC series circuit. At the end of this video, you should be able to explain the phenomena of charging and discharging of a capacitor under constant voltage and under square voltage. Introduction. A capacitor is a main electrical component in the circuits of car's airbag, door's alarm, and flashes of a camera. First, let's remember some of the concepts from the previous year. Definition of a capacitor. Capacitors are electric elements formed of two parallel conducting plates separated by an insulator or dielectric substance and used to store electric energy. The symbol of the capacitor is shown in the figure, and the unit of the capacitance in SI is farad. Characteristics of a capacitor. Capacitance of a capacitor. A neutral capacitor is connected in series to a direct voltage generator and a switch. When the switch is closed, the positive pole of the generator attracts electrons from plate A, which becomes positively charged. At the same time, an equal number of electrons leave the negative pole of the generator and accumulate on B to become negatively charged. During charging, QA, which represent the quantity of positive charges accumulated at plate A, which is at the same side of the positive pole of the generator, equal minus QB, which represent the quantity of negative charges accumulated at plate B, which is at the same side of the negative pole of the dry cell. QA over UAB equal QB over UBA equal a positive constant, which represent the capacitance C of the capacitor. Then Q over UC equals C, which is greater than 0, and the relation between QC and UC is Q equal C multiplied by UC. But QA equal C multiplied by UAB, which is a positive value, while QB equal C multiplied by UBA, which is a negative value. And since C is constant always and positive, Q and UC are always of the same sign. At electric equilibrium, when the capacitor is fully charged, the current in the circuit is 0, and UAB, the voltage across the capacitor, is equal to UPN, the voltage across the generator, which is equal to E, the electromotive force of the generator. Charging of a neutral capacitor. Watch the following video.
Hi and welcome. Today we're going to show you how to use an oscilloscope to measure the voltage across a charging capacitor. This is a circuit you're going to be using. It comprises of a resistor in series with a capacitor. We're going to connect this circuit up to a power supply, a DC power supply here. The next stage is to connect our circuit up. We have the power supply. The positive of the power supply is going to connect to our resistor like this. Sometimes you might just want to give it a quick wrap around the crocodile clip just to get a good connection. And the negative goes onto the capacitor. The capacitor will have a white band which indicates that that's its negative there, and we connect the negative up to that, like so. So there is our circuit, all ready to go. And here we have the oscilloscope, and we're going to use the oscilloscope to measure the voltage across the capacitor. We need to connect the scope. We have two ports here, channel 1, channel 2. It's simply push and twist. The probe itself has a ground clip, and that will connect to the ground of your circuit. There. Just like that. And the probe itself connects to the other side of the capacitor like that. And that is all you need to do to set up the connections for this circuit. Just make that a little, so you can see that a little better. Now that the circuit's set up, we are interested in the reading on the oscilloscope. So we press the power supply on. And we can see the waveform beginning to appear here as the voltage across the capacitor charges. And because it takes 5 time constants to fully charge, it should be fully charged when we have completed 5 divisions on the oscilloscope. So at this point we've done 3, 3.5, coming up to 4. And what we're going to do, we're going to press the run stop button when we reach 5, that's this point here. And we stop it.
Charging and discharging of a capacitor. We are going to start with the charging of a neutral capacitor, which you have been watched in the previous video. The following circuit is used to study charging and discharging of a capacitor. When the switch K is at position 1, the capacitor is in charging phase. The voltage across the capacitor increases exponentially as shown in the figure. Discharging of a capacitor. When the switch K is at position 2, the capacitor is in discharging phase. During discharging, the electric current leaves from the positive plate of the capacitor, which is plate A, and the voltage across the capacitor decreases exponentially as shown in the figure. Application 1. The adjacent circuit is formed of a generator delivering a constant voltage E equal 12 volt, a capacitor initially neutral of capacitance C equal 470 microfarad, and a resistor R of resistance R equal 100 ohm. Charging and discharging of the capacitor. A. The switch is closed at position 1. The following graph represents the variation of the voltage across the capacitor with respect to time. 1. Indicate whether the capacitor is charging or discharging. The capacitor is in charging phase. 2. According to the law of addition of voltage, find the relation between UG, the voltage across the generator, UC, the voltage across the capacitor, and I, the electric current traversing the circuit. UPN equal UAB plus UBD. UG equal UC plus UR, and UR equal UG minus UC. According to Ohm's law, UR equal RI, which is equal to E, the electromotive force of the dry cell, minus UC, the voltage across the capacitor. So I equal E minus UC over R. Referring to the graph, complete the table. We are going to find the values of UC, Q, UR, and I at two instants, t equals 0 and t equal infinity. We are going to use the graph to find the value of UC and the relation between Q and UC to find the value of Q, and the law of addition of the previous part to find the value of UR, and Ohm's law to find the value of I. At t equals 0, UC is equal 0 according to the graph, and by calculation, Q is also equal to 0. UR equal 12 volt. According to the law of addition, UR equal UG minus UC, and UG is constant equal to 12 volt. And I equal UR over R. By calculation, I equal 0.12 ampere. At T equal infinity, according to the graph, UC equal E equal 12 volt. And by calculation, Q equal 0.00564 coulomb. And according to the law of addition, UR equal UG minus UC. 12 minus 12 is equal to 0, and I is also equal to 0, since it is equal to UR over R, which means 0 over R equal to 0 ampere. Summary. 1. Capacitors are electric elements formed of two parallel conducting plates separated by an insulator and used to store electric energy. 2. At electric equilibrium, UPN equal UAB. 3. Relation between a quantity of electric charge Q and voltage U is Q equal CU. 4. During charging, the voltage across the capacitor increases exponentially. 5. During discharging, the voltage across the capacitor decreases exponentially. This is the end of part 1. Study well and thank you for your attention.